A sector with radius 10 centimeters and angle theta is used to form the curved surface of a cone with base radius x centimeters as shown. So a sector with radius 10 centimeters is used to form the curved surface of a cone. You guys understand that? So this bit here is this curved bit here. We get that, right? The volume of a cone of radius r and height h is given by this. That's just, I gave you the formula because some students don't remember it. Show that the volume of the cone described above is given by this. Well, did we do part 1? Okay. So let me do this. 1/3 pi. What's the radius in this case? X squared. Nice. Times what's the height in this case? Pythag. 100 minus x squared. 10 squared. Take beautiful. Done. That wasn't a bad 1 mark. Happy with that? Next one. dv on dx. Oh, I need to take this one to another page. All right, show that dv on dx is equal to that. Did you get it out, Levo? No? What do you need to use if you're going to differentiate this? Product. Okay, so you realize that. That's good. dv on dx, let's do it. Product, so u, and this is v. U dash, so 2 pi x on 3. U dash v plus v dash that's all v dash. Did you get that out? Yeah. Times u. There we go. Yeah, there you go with that. U dash v. Okay, it's obviously got to become this thing. The s is in front of you, so just take your time with it. There's nothing for me to do here, so I'm just going to go 2 pi x root 100 take away x squared on 3. This monster, there's a lot of things that are happening. Minus 2.5 cancels out. I've got x and x squared, that becomes pi x cubed on 3. Now this negative half also goes in the denominator as square root 100 minus x squared. True? Okay, and I think you know what you're going to do with your next line. You should just do common denominator. Fingers crossed, you're pretty much done. So common denominator, you're going to get 2 pi x. Your common denominator is obviously this, which is exactly what they have up here. You're missing the square root, so square root and square root becomes just 100 minus x squared minus, nothing's missing here. Next line, pi x, I'll do it slow, 200, but I think you all know we have it. 200 pi x minus 2 pi x cubed minus another pi x cubed is minus 3, exactly like they wanted up here. Which equals, what did they do? Pi x 200 minus 3x squared on 3 square root 100 minus x squared. Done. That also wouldn't have been too bad. Where'd you go wrong?
You know when
Common denominator?
common denominator, that's the one, yeah.
Yeah, usually is.
I got lost in my algebra.
It's only like just repeat it. So your hand just needs to get comfortable with it. When your hand gets comfortable with it, then your eyes will get comfortable with it.
Yeah.
When your eyes get comfortable with it, your brain's like, yep, easy going, no problem. So that would be a step. Okay, I think we have a part 3. Part 3. Find the exact value of theta for which V is a maximum. We want to find theta. So now we need the expression for theta. So what do we have? We've got radius, which is 10. We know, okay. Let's just talk about it first, because I'm thinking at the same time. So let's talk about what we have and what we need. So if you want to find theta from volume, that means you technically need an equation that has V in terms of theta, right? What you have right now is V in terms of X. So you either have to get rid of X and start again. So you'll have to go deep, get X in terms of theta, and then do, and then differentiate from there. Or the only other thing I can think of is using our rates of change knowledge. In rates of change, if we ever wanted to find dV on d theta, we could have done dV on dx times dx on d theta. The things would have cancelled out. Do you get what I'm saying? So let's see. I don't know. I'm in the same boat as you guys. It's not like I remember every single question, right? We just attempt what we know. So what do we know here? I know that the arc length is equal to 10 theta. I don't know if that's going to help us, but we'll have it in there. L is equal to 10 theta. We also know that, what else do we know? We know the curved area here, the area is pi RL, isn't it? So we know that area is pi times x times 10, so 10 pi x. What do we know the area of this to be? We know the area is half r squared theta, where radius is 10. 10 squared is 100. 100 times half is 50, so this one's 50 pi, or 50 theta, sorry. Oh, there we go. Can you see I have a relationship now between theta and x? I did L, I didn't need it. I didn't know that. I just realized I can't do much with L, so I stopped. I went with the next thing. What's the next thing you learned after arc length? You learned area. Area equals half r, r is 10 squared, theta. That's the area of this. But then the area of this must be the same as the area of this when it's closed. The area of this becomes x as your radius instead of 10 as your radius, and your slant height becomes 10. You get the logic? Now that we have a relationship between 50 theta and 10 pi x, I think, what did I say? 50 theta equals 10 pi x. Now that we have x in terms of theta, which is 5 theta on pi, we can go up and sub it into here and differentiate. Or we could do our knowledge, like I said, of rates of change. The smarter one is rates of change. The more complicated one is sub this back in and then differentiate. That would be silly. So what I'm saying to do is, we want to find theta for V to be a maximum. Essentially, you're trying to find this. We know that that becomes dV on something times something on d theta. What is those somethings? dx. Do we have dV on dx? Yes. That's what you just found above. Do you have dx on d theta? No, but I have x in terms of theta, so I can work out dx on d theta. Dx on d theta is, how do I differentiate this with just theta? It's just 5 on pi, just the constant. Done. dV on dx, see how easy it was? The hardest step was this. And I guess knowing to not do what I just said, subbing it back in and differentiating. Smarter would have been rates of change. So dv on dx is pi x. That was really hard that year for a lot of students because they're just not, I guess you don't spend a lot of time on max-min problems. Your schools will probably do like a lesson or two and that's it. It's not enough for something that will 100% be hard. It's not going to be easy. It will be hard. Don't neglect it. Times 5 on pi. All right, that's dv on d theta. What does it need to equal to now? 0. So make this equal to 0 and start differentiating and finding x. Once you find x, you obviously have a relationship between x and theta. You can sub it in and find theta. Append page. Boom. All right, cross multiply. So that means straight across and then times this one by 0. When this multiplies by 0, it's gone, isn't it? So the whole denominator, I'm just going to ignore it. If that's okay with everyone, I'm just going to write pi x. That's why they factorized the x out for you guys. Fair enough. So you can see they did that so that it's easy for you to solve at this stage. X equals 0, you ignore everything else. X equals 200 on 3, and then you got to square root it. You can see that? Happy? Done? But it didn't say to find x, it said to find theta. So x equals to this, so therefore theta equals to, what do we have? 5 theta, so x equals 5 theta on pi. So root 200 times pi divided by 5. I found theta, I've got to make sure it's a max. So differentiate again. D squared v on d theta squared equals, all right, differentiate. All right, now, are you going to do second derivative of that? No. That, you heard me laugh about it. There's no way. Why would you want to do second derivative? You're going to do quotient rule. That's just silly. You might as well have done this. So what's this number as a decimal? Square root 200 on 3 times pi on the outside, not attached, divided by 5. That number is about 5.13. So you're going to not do second derivative. What's the method called, Novak? Y dash table. .13, so we'll choose 5 there, and I think we'll choose 5.5 there. We're going to sub 5 and 5.5, or I'm going to sub it into this thing right here. Okay, pi times 5, bracket 200 minus 3 times 5 squared on 3 root 100 minus 25. We'll just write 5 squared. 75. So that one became 75. We're hoping to get a negative now. We're hoping to get a negative. What number do we want? 5.5. 5.5. You can see why you also need to work fast. Things take time. Still gave me 75. Ah, crap. What have I done wrong? Did I sub something in wrong? 200 minus 3x squared. I know where it should have been negative 3x. No, something's wrong. Something is wrong. X equals this times pi divided by 5. Root 200 on 3 times pi divided 5. Yeah, that's right. Something is weird. What has happened? Maybe when I got rid of my 0 here, and so we'll go back this. Times by 5, yep, that's fine. 200 minus 3x squared. And then minus 200, then you divide, you get 200 on 3, square root it. That looks right to me as well. Can't pick it up, so we don't waste time. Let's just go and see where I'm going wrong. Damn. That's annoying. Marking guidelines. Where did I go wrong? Triple I, dv dx, x equals 200 on 3, 8 and 9, 200 root 200 divided by root 3, 8.16, what the heck do I have? X equals exactly theta. Something weird. Let me think. Realize what they've just done. I realize what I've just done. X equals, yes. And I've got my theta relationship, yes. I should have finished it off for X, but why? Why? I'm doing dv on d theta. One is f value for which v is a maximum. V. V in terms of x. Okay. Incorrect. Incorrect. That would have been crap. Alright, the part where I went wrong is to make v a max, v has to be in terms of x. The only part where I went, probably I got sidetracked, is the theta bit. I went, oh yeah, I need to make v in terms of theta. But what it is, it's telling you v, not volume, v as in v, this v, which is in terms of x. So I can't actually go and find volume in terms of theta. It's not asking me to do that. It wants this volume with x to be a maximum. So the fact that I did this step would actually be wrong. You don't need to find it like that, which means even initially, I could have just made dv on dx equal to 0. So you could have made here, this component here, equal to 0, which is exactly the same as what we've got here, except I've got the times 5 on pi, which doesn't make a big difference in terms of your math. So you'll still end up with the same result. X is this. You'll do your maximum for that, which is now 8.16, so you'll choose 8 and 9. And obviously this one's going to be positive, this one's going to be negative, which means it will be a max, which is great. You found x, but you needed to find theta. So your theta would be what we had written before. Pi root 200 on 3 all over 5. That is the theta. I went and tried to find the theta of this, the volume of this theta, which doesn't work out like that. It's meant to find where the volume in terms of x occurs. So, my bad. I was doing the wrong one. So same solution. I didn't do anything too incorrect. It's just my volume. I should have read it again. I was rushing. That's fine. All good? Silly mistake. Don't do it. Let's go again. Well, I can see we don't have much time. I think instead of doing another one, let's see if I can find, there it is, 5, 7 marks. At least keep going with these, making sure these are not done bad as well. Start points, nature, 3 marks. Given that this point lies on the curve, show that it is also a point of inflection. Sketch the curve, show the stationary points of 2 marks. So altogether, 7 marks. So homework, don't forget, exercise 3 and then the 2 prelims. One's extension 1, one's advanced.